Unit 6, Day 3, Similar Triangles. There are three postulates for proving triangle similarity. They are AA, SSS, and SAS. When we talked a couple of months ago about triangle congruence, we named 5 postulates. However, this is triangle similarity, and there are only 3. The first one we're going to talk about is called AA, and that stands for angle. So basically, any triangle that has 2 angles that are the same, we can just go ahead and say that the triangles are similar. There are times when they give you information and it's not enough, and you may have to find the 3rd angle. However, we can clearly see that this is 75, this is 75, this is 31, and this is 31. So these angles are congruent. So these triangles are congruent. And so we have to write a statement, and so our similarity statement is going to be triangle ABC is similar to triangle DEF. So just make sure angle A, which is 75 degrees, is congruent to angle D, which is 75 degrees. Angle B, they don't have anything there, but we figured it out, is 74, is congruent to E. C is congruent to F. You have to make sure your order is on point. I will leave number 2 and have you to do it. Hopefully, you were able to determine that these angles here are vertical angles. Therefore, the triangles are similar based on the postulate AA. And go ahead and write a similarity statement. So here we go. Triangle VWX is similar to triangle YZX. And I made sure that I stayed within the proper order. The next one we're going to talk about is side. And not that all the sides have to be equal. I mean, that'd be great. We could say they're similar, but we need the sides to be proportionate. And so you always have to check. So we're going to check small triangle to big triangle, and I'm going to write down all the numbers. I like to do stuff small, medium, and large. So on this triangle, it is 3, 4, and 5 are the sides. And in my other triangle, it is 6, 8, and 10. Since all of these scale factors reduce to 1/2, these figures are similar. So we could write a similarity statement. And if you would write the similarity statement, I'd appreciate it. I'm going to go on to number 4, and I'm going to write the numbers down from least to greatest. So I'm going to do 30, 32, 35 for my first triangle, and I'm going to compare that to my second triangle in order from least to greatest: 24, 25, 28. 24, 25, 28. Now what we want to do is we want to simplify this to make sure they all have the same scale factor, because if they don't, then they're not similar. So when I reduce these fractions, the first one gave me 5/4. The next one is as simplified as it can get, 32/25. And then the last one, I got 5/4 again. Well, the answer here is no, because if they're going to be similar, we needed all of these numbers to be the same, and they are not. This next one is side angle side. So we need the sides to be proportionate, but we need the angle to be congruent. So when I look at this, I have the congruent angle, so I just need to make sure the sides are proportionate. So what I'm going to do is I'm going to do least to greatest. So this is 8 and 20 from the one triangle, and I'm going to put it over least to greatest of the other triangle, which is 6 to 15. Okay, these both reduce to 4/3, so they have the same scale factor. So definitely they are similar. We can come off to the side and write our similarity statement, and the statement would read that triangle JKL is similar to triangle MNP. Let's take a look at number 6. Number 6, as you can see, these triangles are inside each other. So we have triangle ADE right here, and then we have the larger triangle, I'll sketch it in blue, which is triangle ABC. So we got a lot going on here. So let's take a look and see Well, first of all, the angle here in the small triangle matches the angle in the large triangle because it's the same. So we may be able to get side angle side, but we need to make sure that the sides are proportionate. So let's look at the little triangle. The sides are 15 and 12. Now we'll put that over the large triangle, which is 25 and 21. Four over 7. So are they similar? No. How come? Because they have a different scale factor right here. So the answer here is no. So now we put it all together by doing some practice problems. First practice problem, we always want to recognize vertical angles and mark those. We also notice there are parallel lines. If we have parallel lines, we have an angle pair relationship. Alternate interior angles are definitely congruent. So are these figures similar? The answer is yes. What's the postulate that proves it? It's called AA. With this particular problem or problems like these, you always want to fill in the given information. We already see we have an angle congruent to another angle. However, we're missing information. So all the angles in a triangle add up to 180. So we find out the angle S is 51 degrees, and also this is 51 degrees. So do we have two angles congruent to two angles in the other triangle? Yes, we do. Are the triangles similar? Yes, they are. What's the postulate? It is AA. Next, this one, we see three sides. So we're going to see if these are similar based on side, side, side. So I'm going to write these sides in order from least to greatest. I'm going to do 9, 13.5, and 27. And I'm going to put that over the sides of the other triangle in order from least to greatest. So that's going to be 14, 21, and 42. So when I simplified each of my fractions, I got 9 over 14, 9 over 14, 9 over 14. So that is the scale factor. Are these triangles similar? The answer is yes. What's the postulate theorem that proves it? It is side, side, side. Here's one. You can try it. Tell me if it's similar. Write the postulate, pause, and then come back and see if your answer is correct. Here we go. I wrote my sides as a ratio, and then I simplified, and all of these are different. And so are they similar? The answer is no. So you do have to check the sides to make sure they're proportionate. This particular problem here, first thing you always want to recognize and mark, vertical angles. So if these triangles are similar, we're going for side angle side. We have the congruent angle. Let's see if the sides are proportionate. I'm going to do small, big. So I'm going to do 6 and 12. And I'm going to put that over the other triangle, small, big, 24 and 48. Do you have to do it this way? No. Some students may want to do big to small. But whatever it is, you must stay consistent. Here we have it. We have our fractions, 6 over 24 and 12 over 48. We simplify those. We get 1/4. So are these triangles similar? The answer is yes. What's the postulate that proves it? It is side, angle, side. Okay, here's our last example. What do you notice? You should see the arrowheads for parallel lines. Anytime there are parallel lines, there's an angle pair relationship. And the angle pair relationship is going to be corresponding angles in this case. So this angle here is congruent to this angle here. We're potentially looking at side angle side because we have a side, an angle, and a side. So let's go ahead and set it up, see if it's proportionate, and declare it either similar or not. So I write the two sides of my triangle on the left from least to greatest. That's 36 and 54. Both fractions simplify to 18 over 11, so they are definitely similar. One thing that we didn't do on these problems is write similarity statements. So make sure you do an additional 4 or 5 problems, write all the similarity statements, show it to your teacher.